Right now, there are literally thousands of objects orbiting our planet. Everything from the massive International Space Station down to tiny bits of old rocket. So how do we stop all of that from turning into total chaos up there? Well, the answer is a surprisingly simple tracking system, and we're going to break down exactly how it all works. I mean, just think about it for a second. It's a wild problem. You've got this invisible highway of objects just whipping around Earth at insane speeds. Trying to manage all that traffic, it's one of the biggest challenges of our time. And you know what? The solution to this cosmic traffic jam is actually kind of beautiful. It's this elegant idea that brings order to all that chaos. And it all boils down to one single unique number that gets assigned to every single thing up there. So first, let's just set the scene. Earth's orbit is crowded. No, I mean, it is really crowded. It's full of the active satellites we depend on every day, sure, but it's also full of old, dead satellites, leftover rocket bodies, and just countless pieces of junk. Keeping track of this crazy dynamic environment is absolutely critical. Okay, so how in the world do you do it? Well, you give every single object its own unique license plate. That's really the heart of the whole system we're talking about today, a totally straightforward solution to an incredibly complex problem. This license plate has an official name, of course. It's the NORAD ID, which is also called the satellite catalog number. And it's pretty much what it sounds like, a unique number that gets assigned to every single tracked object in orbit. No two things ever share the same number. Simple as that. And that license plate analogy, it's just perfect. You know, just like a license plate identifies one specific car on a packed highway, a NORAD ID lets you pinpoint one single object, whether it's a brand new satellite or a piece of debris, in the absolute vastness of space. So who's the DMV of space, right? Who hands out all these numbers? That would be the North American Aerospace Defense Command, or NORAD. They're the ones who keep this master catalog, making sure every single object has its own unique tag. All right, so what actually gets one of these IDs? You might be surprised. It's definitely not just the big, important working satellites that get cataloged. The breakdown here is what's so fascinating. Of course, active satellites get an ID, but so do the defunct or dead satellites. So do the big upper stages of rockets that are just left floating up there, and even big pieces of space debris get a number. Basically, if it's large enough for us to track it from the ground, it gets an ID. To make this a little less abstract, let's look at a couple of famous ones. The International Space Station, that huge orbiting lab. It has the NORAD ID 25544 and a specific GPS satellite, USA 232, one you might be using every single day without even thinking about it, that's tracked as number 37753. Okay, so everything up there has a number, but what do we do with that number? This is where the NORAD ID goes from being just a label to being an incredibly powerful tool. It's the key to predicting an object's every move and for making those split-second decisions to avoid a disaster. Now, this is a really important point to get. An object like the ISS actually has a few different names. It has its human-friendly name, ISS. It has something called an international designator, which tells you about its launch. And then it has its NORAD ID, 25544. And that's the one that's key for tracking its orbit. So the crucial thing to remember is that these are not interchangeable. The name is for us humans, the designator is for its historical records, but the NORAD ID, that's the one that's used for the minute-by-minute, real-world work of tracking and making sure things don't run into each other. And this is pretty much how that work flows. It's a simple but really powerful process. First, you use the NORAD ID to find the exact object you're interested in. Then, that ID is like a password to get its orbital data, which is called a two-line element set, or TLE. Once you have that TLE data, you can calculate the object's precise orbit and predict where it's going to be at any time. This data is the absolute backbone of the whole space surveillance network. And what's really cool is that a lot of it is actually available to the public. You can go to amazing websites like Celestrak and Spacetrack, punch in a NORAD ID, and look up the data for thousands of objects yourself. So why are we talking about this? Why does a simple number matter so much? Because it is the fundamental key that unlocks our ability to do anything safely in space, which in turn supports so much of our modern life down here on Earth. And look, if you work with GNSS or any other kind of space system, this is all very familiar. The NORAD ID isn't just some abstract thing. It's a tool you probably use every single day. It's absolutely essential. It's essential for pulling that TLE data to figure out where something is headed. It's the very foundation of what we call space situational awareness, or SSA, which is really just a fancy way of saying knowing what's up there and where it's going. It's what allows someone to see two objects are getting too close and command a satellite to move out of the way. It's what makes managing this whole crowded sky possible. So, if you take away just one thing, let it be this. The NORAD ID is the unique, globally used number that lets us identify and track pretty much any object in Earth's orbit. It's the simple, elegant solution to a massive, messy problem. And all of this leaves us with one final big thought. This system has worked incredibly well for decades, but right now, companies are launching thousands upon thousands of new satellites, creating these so-called mega constellations. The sky is about to get way more crowded than it's ever been. So the question is, will this simple license plate system be enough to keep our future in space safe and secure? That's the challenge we're facing right now.